Hello, we are Group 8 from Division B and we would be telling you what is a motherboard and its components. These are our group members: roll number 42 Arya Bhatkadli, roll number 43 Abhilash Baviskar, roll number 44 Gajanan Baviskar, roll number 45 Neeraj Baviskar, and roll number 46 Sarthak Baviskar.
Hello all, welcome to our in-depth exploration of the main components of a motherboard. A motherboard serves as the central circuit board that interconnects all the crucial components of a computer, allowing them to communicate and work together seamlessly. Today, we will delve deeper into the 5 primary components that make up a typical motherboard. The CPU socket, also known as the processor socket or CPU slot, is a physical interface on the motherboard that serves as a connection point between the central processing unit (CPU) and the motherboard itself. It is specifically designed to house and secure the CPU, allowing it to function as the brain of the computer system. The CPU socket plays a crucial role in establishing both mechanical and electrical connections between the CPU and the motherboard. It provides a secure attachment mechanism that holds the CPU in place, preventing any movement or dislodgement during operation. This is achieved through a latch or retention mechanism that varies depending on the socket design. Beyond the mechanical aspect, the CPU socket also serves as an electrical interface between the CPU and the rest of the system. It features an intricate array of pins or LANs that align with corresponding contacts on the underside of the CPU. These pins or LANs establish electrical connections, enabling the transfer of data and power between the CPU and motherboard circuit. The number and layout of pins or LANs on a CPU socket depends on the specific socket design and manufacturer. Each CPU socket type supports a specific CPU family or generation with unique pin configuration tailored to fit the corresponding CPU's contact pattern. It is important to note that CPU sockets are not universally compatible across different CPU manufacturers or generations. This means that each motherboard is designed to support a specific range of CPU socket types. For example, Intel motherboards typically support Intel compatible sockets such as LGA land grid array, while AMD motherboard supports AMD compatible sockets such as AM4 Advanced Micro Devices socket AM4. Selecting a compatible CPU for your motherboard involves ensuring that the CPU socket type matches the socket supported by the motherboard. Placing an incompatible CPU into a motherboard socket can result in physical damage or at the very least the system failing to boot. CPU sockets can also undergo revisions or updates within the same socket type. These revisions may introduce changes to power delivery capabilities, increased pin count, or support for newer CPU generations. It's crucial to consult the motherboard manufacturer's documentation or specification to determine which CPU socket revision is supported by your motherboard. In summary, the CPU socket on a motherboard is a specialized interface that provides both mechanical and electrical connections between the CPU and the motherboard. It ensures a secure attachment of the CPU while enabling the transfer of data and power. Choosing a compatible CPU that matches the socket type supported by your motherboard is essential for proper functionality and system compatibility. Thank you.
RAM slots, also known as memory slot or DIMM slots, dual inline memory module slots, are physical connectors on a motherboard specifically designed to accommodate RAM random access memory modules. RAM is a crucial component in a computer system as it provides temporary storage for data that the CPU needs to access quickly. The number and configuration of RAM slots can vary depending on the motherboard module and form factor. Commonly, desktop motherboards have 4 RAM slots, while some smaller form factors like mini ITX may have only one slot. Workstation or server class motherboards may offer even more slots to accommodate higher memory capacities. The primary purpose of RAM slot is to provide a secure mechanical and electrical connection between the motherboard and the RAM modules. The slots are designed to match the physical specifications of the RAM modules, ensuring a proper fit and alignment. Typically, modern motherboards employ a DIMM dual inline memory module design where a RAM modules have pins on both sides that insert into the slots. It's essential to note that RAM slots are often labeled or color coded to indicate the recommended configuration for installing RAM modules. This is particularly relevant when using multiple modules to achieve optimal performance and enable dual channel or quad channel memory modes. Following the manufacturer guidelines and consulting the motherboard user manual can help ensure the correct placement and configuration of RAM modules. Another critical aspect to consider when working with the RAM slot is the supported memory type and speed. Different generations of RAM such as DDR3, DDR4 or DDR5 have varying physical and electric characteristics. Motherboards are designed to support specific memory types and the RAM slot are configured accordingly. It is important to verify the supported memory types and maximum speed specifications of the motherboard to ensure the compatibility with the RAM modules you intend to install. Furthermore, it's worth mentioning that some high-end motherboards may feature additional technologies like ECC error correcting code RAM support. ECC RAM is primarily used in critical systems where data integrity is of utmost importance, such as server or of workstations. These specialized RAM modules have extra error checking capabilities to detect and correct data errors, offering a improved reliability. RAM slots on a motherboard provide the physical interface for installing RAM modules. They ensure proper alignment, electrical connectivity, and mechanical stability. By following manufacturer guidelines, considering the supported memory types and speeds,
Expansion slots
configuring the
play a
module
vital role
correctly,
in
you can
expanding the
optimize your
capabilities
system
of a
memory
computer
capacity
by allowing
and
users
performance,
to add
enabling
additional
smooth
hardware components
multitasking
known
and
as
efficient
expansion
data
cards
access.
to their system. These cards can enhance various aspects of a computer's functionality, such as graphic processing, audio output, networking, storage, and more. Expansion slots adds as connectors on the motherboard that provides a means of communication and data transfer between the expansion cards and the rest of the system. The most common type of expansion slots used in the modern motherboard is the PCI Express slot. PCIe slots come in different sizes, typically referred to as X1, X4, X8, or X16, representing the number of lanes available for data transfer. The larger the number of lanes, the higher the bandwidth available for the data exchange between the expansion card and the motherboard. These PCI slots have replaced the older PCI slots, which are still present on some motherboards but are gradually being phased out due to their slower data rates and limited capabilities compared to the PCI. To install an expansion card, such as graphics card or a sound card, you would align the card's connector with the corresponding slot on the motherboard and gently insert it until it is securely seated. It is important to note that expansion cards come in different form factors such as full size, half size, or low profile, and you need to ensure that the card you choose matches the physical dimension supported by your slot and the computer case. Once installed, the expansion card establishes a direct connection with the motherboard, allowing it to interact with the system resources such as the CPU, memory, and the other peripherals. This enables the expansion card to perform specialized tasks and offload certain functions from the CPU, resulting in enhanced performance and functionality in specific areas. For example, a graphics card inserted into a PCIe X16 slot can handle the complex processing required for rendering high quality graphics in games or graphic design applications. Similarly, a sound card inserted into an available PCIe slot can provide superior audio output, delivering high fidelity sound for multimedia experiences or professional audio productions. Besides PCIe slots, motherboards may also include other types of expansion slots, albeit less common. These may include legacy slots like PCI slots for older devices, as well as specialized slots like M.2 slots for high speed solid state drives or U.2 slots for enterprise grade storage device. Understanding the capabilities and limitation of expansion slots on a motherboard is crucial when customizing or upgrading a computer system. It allows you to select the appropriate expansion card that cater to your specific needs and expand the functionality and performance of your computer in a way that aligns with your requirement. By leveraging the power of expansion slots, you can tailor your system to meet unique computer demands, whether it's for gaming, content creation, professional application, or any other specialized task.
The chipset is a collection of integrated circuits that play a crucial role in controlling and coordinating various functions of the motherboard. It serves as the communication hub between the different components of the computer, ensuring smooth data flow and facilitating the interaction between CPU, memory, storage devices, expansion slots, and other peripherals. The chipset consists of two primary components, the north bridge and the south bridge. Each component has distinct responsibilities and functionalities. North bridge, traditionally located near the CPU socket, is responsible for managing high-speed communication between the CPU, RAM, and graphics card. It handles takes tasks such as memory controller operations, AGP, or PCLE communications, and provides a dedicated pathway for efficient data transfer between the CPU and memory. On the other hand, the South Bridge is responsible for managing the slower speed connections and I/O functions of the motherboard. It handles tasks such as USB ports, SATA ports for connecting storage devices like hard drives and SSDs, peripheral component interconnect slots for expansion cards, networking interface, audio inputs and outputs, and other peripherals. The South Bridge also provides support for legacy interface such as PS2 ports or keyboards and mic and older parallel and serial ports. The chipset also plays a significant role in determining the overall feature and capabilities of the motherboard. Different chipsets offer varying levels of support for CPU overclocking, memory frequencies, and timings. Multi-GPU configurations, USB or SATA port counts, networking capabilities, and other advanced features. Therefore, when choosing a motherboard, it is essential to consider the chipset model and its specific feature to ensure it aligns with your desired system requirements and future expansion plans. Chipsets are developed by motherboard manufacturers in collaboration with CPU manufacturers such as Intel and AMD. Each CPU generation typically requires a specific chipset version to ensure compatibility and take advantage of the latest features and technology offered by the CPU. As technology advances, chipsets evolve to incorporate new standards, protocols, and improvements in performance and efficiency. New chipset release may introduce support for faster memory types, increased PCLE lanes, improved power management, updated USB standards, or enhanced connectivity options. In summary, the chipset on motherboard acts as the central control hub, facilitating communications between various components and peripherals. It consists of the North Bridge and South Bridge component, which handle high speed and low speed connections respectively. Understanding the chipset model and its capabilities is crucial when selecting the motherboard and that suits your specific needs, ensuring optimal performance, compatibility, and expandability for your computer system.
Storage connectors on motherboard serve as the interface between the motherboard and various storage devices, enabling data storage and retrieval. These connectors provide the necessary data and power connections to establish communication between the motherboard and storage devices like hard disk drives and solid state drives. The two most common types of storage connectors found on motherboards are SATA and M.2 connectors. Let's explore each of them in more detail. First one, SATA connectors. SATA connectors are widely used to have been the standard for connecting storage devices for many years. These connectors feature a small rectangular shape with a series of metal pins or slots. They support the serial ATA interface, which allows high-speed data transfer between the storage devices and the motherboard. SATA connectors typically come in two variations, SATA 2 and SATA 3. The latter offers faster data transfer speeds, making it ideal for SSDs and other high performances storage devices. SATA connectors also provide power connections, ensuring that the storage devices receives the necessary power supply from the motherboard. Motherboards usually have multiple SATA connectors, allowing you to connect multiple storage devices simultaneously. These connectors are often color-coded to differentiate between the different SATA ports and indicate their speed capabilities. M.2 connectors. Second, M.2 connectors, also known as next generation form factor connectors, representing a newer and more advanced storage interface found on motherboards. They have gained popularity due to their compact size and high-speed data transfer capabilities. M.2 connectors are smaller, resembling a smaller rectangular module or card slot on motherboard. They support NVMe protocol, which enables lightning fast data transfers rates compared to traditional SATA connectors. NVMe SSDs, when paired with M.2 connectors, can deliver significantly improved storage performances, reducing data access and transfer times. M.2 connectors support various lengths and key types denoted by numbers like 2242, 2260 or 2280, and keys like B, M and B plus M. These specifications determine the physical size and compatibility of M.2 storage devices that can be used with the connector. It's crucial to ensure that the M.2 storage devices matches the length, key type and supported interface SATA or NVMe of the M.2 connector on a motherboard for proper functionality. Many modern motherboards offer multiple M.2 connectors, allowing users to expand their storage capacity with high-performance SSDs while maintaining a clutter-free system design. By utilizing the appropriate storage connectors of your motherboard, you can seamlessly connect and utilize storage devices, providing ample space for data storage, faster data transfer speeds, and overall enhanced system performance.
And there you have it, an in-depth exploration of the 5 main components of a motherboard: the CPU socket, RAM slots, expansion slots, chipset and storage connectors. Understanding the roles and functionalities of these components is crucial when selecting or upgrading a motherboard for your computer. By choosing the right motherboard, you can unlock the full potential of your system and enjoy enhanced performance. Thank you for joining us on this journey.